PHP code very strong, and sometimes we cannot decide how can we decouple such cross-cutting concerns from our application. And of course, I will make a presentation about my framework, and we will look how can we implement async methods in PHP with aspect-oriented paradigm. And for the dessert, I have good quality stuff about hacking the PHP itself, which should be interesting for advanced developers, and you will learn some crazy stuff. Okay, let's begin by looking at boundaries. The first boundary is very well known, called open-close principle, and it stands for the principle that you can extend your class, but you cannot modify your parent class, you cannot change your behavior, and it looks very simple that we have a final class, and if we want to extend this final class with our child, of course it won't be possible because the class is final. It's a simple boundary. The same is for final method. If we have a final method and we want to override such a final method in our child class, it's also impossible because this method is final. This boundary is so fundamental that prevents us from mocking final classes in our unit tests, and we also trying to find a way how can we mock such a final class, or how can we, for example, override the method that was declared like final. And sometimes we have a private modifier, and maybe we need to call a private method somehow, but framework decided to declare all the methods like private and final. Don't touch my thing, it's my own. And when we want to call such a private method, we will get a typical error about method declared as private, so we cannot call it, we cannot modify. That's it. We also have some fundamental boundaries in PHP itself, because PHP is a very complex thing, and interpreter. Raise your hands, just. Okay, so only one person thinks it's PHP interpreter? Oh my God. Actually, PHP interpreter. And who thinks that PHP is compiler? Okay, one more person thinks it's compiler. What about another person? So neither interpreter or compiler? Yeah, actually the right answer is both. PHP has so many cool optimizations that if we want to execute our PHP script, what's typical done? We're trying to execute the method, but PHP need to first to parse it. At this point, we need to analyze the structure of your PHP file. We need to compile such structure into the opcodes, and after that, PHP will be able to execute it. So there is virtual machine called ZenVM that actually performs step-by-step execution of your original source code. So it's kind of interpreter. But if we want to optimize such a thing, we can optimize it by moving compiled opcode into the opcache. And from this point, PHP is not interpreter anymore because we can put the whole structures into the memory, like bytecode or even C code into memory and execute it like compiled version of your application. And there is fundamental restriction that if we have a compiled version of our application in memory, we cannot modify it in runtime. For example, if you have a class, you cannot add a method in runtime. If you have, I don't know, some, for example, function, you cannot remove it in runtime. Of course, you can declare a new one, but you cannot modify existing one. Let's check what's stored actually in opcache and why it's important part of PHP. First of all, it's a fixed size block in memory, allocated only once, and it contains binary structures. So if you look at PHP from the C side, there are structures like then class entry, zval, then function, etc. And all the structures are immutable by default because if structures are immutable, it's easy to share such structures between our process and execute them without copying from each request. And opcache is append-only structure because if we can, for example, free some structure memory, allocate new ones, at some point we will end with defragmented memory, and it will require a lot of time to proceed your request by copying parts. Well, structures like file functions in hash tables, file classes, main operation code array for your script, and several structures like internal strings, immutable arrays. We can store metadata like our version about system, which executes such a PHP script. Okay, so we have some restrictions from the opcache, and such restrictions apply to all PHP environment, and we cannot redefine or delete method in runtime. We cannot modify inheritance structure, so if we have like class A extends class B, we cannot in runtime change, say, like class B extends class C. It's impossible. And if you have low-level access to our memory, we can damage it, but opcache prevents such a low-level access, and this is our fundamental boundary. But at the end, we will break it. Of course, it's possible to install some cool extensions like uops, like runkit, and actually it's a first escape. So we can escape from our boundary, like how can we mock or extend a final class, or how can we override a final method. Can we do that? Yes? Okay. There are persons who think we can do this, and who vote for no? Okay, several persons. Simple solution, not to to mark your class or method like final, because it's easy. And but sometimes you have a framework restrictions or like vendor application with final classes. And for this case, you can just install uops extension, which was written by Joey Watkins. It's a famous guy who creating cool extensions in PHP like pthreads, like UOPS, and much more. But you should know that UOPS is a very black magic extension. You can use it to escape from final method or final class boundary, but I'm not a good one who knows this extension well. So I decided to show you how can we mock a final class. We need just call one simple method called UOPS flags. And what actually happened at this moment, we access then class entry structure for final class test, and we just remove the final flag from this structure. If you look at the PHP source code, we can find a place where PHP checks if class is final or not, and if there is a final flag, it prevents inheritance. But with UOPS flags function, we can remove such a flag from our class, and voila, we can extend it without any troubles. So if we check with reflection if class is final or not, we will get that class isn't final. The next cool feature is the file stream wrapper that allow us to hack PHP from internal side. Like there is a file stream wrapper, and it's used for all includes all file operations by default in PHP, and we can unregister this file stream wrapper and register our own stream wrapper that can proceed all of our source code and replace the final keyword in our source code with just empty string. And from this point, we can extend final class, we can mock a final method without troubles. And after that, we can return this transformed source code back to the PHP, and it will compile such code into executable one. But there is a library called DG bypass finals. You can just install this library in order to mock your final method or final classes. And this feature is available with only one single call called bypass finals enable. And if you put this line in your afterload script, it can proceed to all following files in your application and remove all final keywords from your source code. If you want to read an article by Tomasz Wojtuba, there is additional details how to integrate with PHP. You need such a library, and it provides you a good API. I also want to mention one cool library called Patchwork. It provides a good API for method redefinition. It do almost the same, trying to analyze your source code, removing final keywords, mocking default functions in PHP. So it's kind of transformation of your source code via special stream wrappers, and it gives you control over the structure of PHP code itself. And next escape is PHP stream filter. Actually, it's quite interesting and is used in my framework called GoLP. Let's have a look how it works. First of all, we have simple file like hello world, and we want to craft a special include. This include isn't a typical one because it contains PHP filter prefix in it, and this instruction use a filter called string to upper to transform our PHP source code on fly. And if we execute it, we will get a hello world, but notice it's uppercased. This feature is so cool that you can transform your source code on fly, and you can create your own stream filters. like analyze an abstract syntax tree of your source code, transform it, replace token like final with empty string. You can control special constructions or even write your own language. For example, proceed with special constructions like generics, like templates, and you can do almost everything. Moving on to the next part of my presentation is about cross-cutting concerns. Who knows about cross-cutting concerns? What are they? Okay, only few people. These cross-cutting concerns are very problematic part in object-oriented programming, because if we want to use typical classes or typical objects for almost everything, we can notice that sometimes we need to write a code like not in classes but put into the class itself. And cross-cutting concerns are aspects of our application or maybe of our domain that affects another parts of your application. And it's not so easy to understand if you have cross-cutting concerns in your application, but definitely they're present because object-oriented paradigm has a limitation of representation of real life. For example, there is a cool quote from Joy Armstrong that if you want a single banana, what you get is a gorilla holding banana and an entire jungle. It's like if we want a class car, we need to create a class wheel, we need to create a class engine, connect them, like this. I want to show a simple example of cross-cutting concerns, like let's implement a system that will perform a security audit of our calls to public method. Like if we call this one method, let's write into log that this method was called. And we have a pretty cool simple method called create new user. It's simple one, only 4 lines, nothing special. Respects all the principles like single responsibility, keep it simple, stupid, whatever. But such a method is good until we need a requirement to write or maybe check that our user is actually an administrator in this system. Okay, just put several lines with checks about if it's granted or not to perform such operation. But then we need to check actually if we created such user or not, and okay, 2 more lines, and we log information if we created user or not. Looks good. Let's proceed further. We have error handling. It's a typical one code that we can have in our application, just to write try, catch section, and write about that something went wrong, and we need to recover somehow from such an exception. And at the end, we need to handle maybe additional stuff like transactions or maybe anything else. I want to ask if you have several same code in your application. Yeah? 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 Please raise your hands. Actually, we started with only 4 lines, and what we have at the end, we have like 13 lines in our application, like in our method. And we can notice similar parts. So if we look at another one method, we will notice there is a green area, like main logic. We notice that there is an area with error handling, and actually we have special checks for authorization. This unpleasant code is called tangled. We have main logic, we have logic for authorization, we have logic for error handling, and we have logic for logging. If we look at the next one method, for example, delete new user, delete user, we can imagine that it will also contain the same lines like if this security is granted role administrator, okay, let's proceed. And these several lines will be duplicated in every class and every possible method in your application. This results in a scattered implementation, so we have logging, but okay, do we have actually only one single logging class in our application? No, we have logging in this class, this one, we have everywhere. And the typical picture of cross-cutting concerns in your application will be something like that. So we have your original class and we have cross-cutting concerns across such files everywhere. Of course, it's not easy to support such a mess because if we want to mock typical class, we need to create a mock for logging interface, we need to create mock for authorization service, we need to pass such mocks everywhere in every possible test. But there is a solution called aspect-oriented paradigm. Actually, it was invented many years ago, but for PHP isn't very known well. And the idea is very simple, to extract such cross-cutting concerns from classes and put them into separate entities called aspects. Let's have a look at this one method and try to extract such lines into authorization aspect and have a look how can we do this. Okay, so what's the aspect is? It's a typical class that contains dispatcher from our method, and we have an advice. So advice looks like, before you execute this method, let's check if user is administrator or not. Simple one, like advice in our typical life to wash your hand before you start to eat. And we have point cards, it's kind of SQL expression on your source code. Here we declare that we want to intercept every possible method in user service class, marked as public. And before execution of such method, let's perform execution of our advice. And we also have event itself, it's execution of our method. We can easily compare AOP with event dispatcher or event listener because they are very similar in several parts. Like we have initialization part for aspects and for event listener. We have kind of expression what we want to listen to. For example, we want to listen to event or we want to listen to execution of methods. And we have some logic like advice. With AOP, you can apply advice before execution of your method, after execution of your method, or around. So you can wrap the execution of original method with your own callback, like to perform caching. And for example, check if we have cached version in cache, then just return it. And with AOP, we can subscribe to any method without changing our source code, and it's only on fly. So you can just define a handler for logging, for caching, and not to worry about creating special parts in your application to produce an event like check if user is authorized event. Name of this framework is Go AOP. And you can install it like typical library in your application by requiring GoOP framework and use a special integration with framework if it's possible. I want to show you how it works. It's to understand how can we transform source code on fly. First of all, we need to register stream wrapper. It's our hook, it's our transformation tool. And we need to wrap a composer. So every time composer tries to load original source file, we transform it with our PHP filter prefix and receive or control over the content. And after that, we can use a wonderful library, Nikic PHP parser, to create an abstract syntax tree of your source code. And on top of that, we can create a reflection. It's a library called GoAOP parsed reflection. It provides all information about your source code, but without extra details like without loading classes into memory. And after that, we can transform our source code and put a transformed version into the cache. Okay, here is an example of a generated class. It's like a decorator one and use a simple inheritance. So we can notice that we have user service class, but it extends class called user service proxy. It's original version of our class, but renamed. And we have a simple method override that executes our logic. I want to show you an example of deferred method. How can we introduce it? Let's start with example, for example, method that takes some time, for example, several seconds to execute. And we want to make it deferred, to stop the FPM worker from waiting us for the end of the script. It is pretty simple, is to keep this method until the fastCGI finish request is called and perform in background. For that, we create an annotation. I like annotations, by the way. We need to define an aspect which will intercept execution of every method called deferred with annotation. And we define handlers that will collect all such methods into the variable called delay method. And we prevent the execution of original method. It's the key idea. It just return simple empty result or maybe promise if you want. And after that, we can register shutdown function on PHP terminate, and we can terminate current fastCGI request by executing fastCGI finish request and execute all delayed methods by step. So we just need to put one single annotation before our send push notification method to make it deferred. So if we call it now, it will be deferred and finish immediately. And okay, moving on to the most interesting part of my talk about hacking the PHP engine. I want to put this slide. What we have in PHP 7.4 is foreign function interface, which is available from PHP 7.4. It allows calling us C functions, allows us to use C structures, opens a way to write PHP extensions in PHP, and headers can be preloaded during server startup, so we can load our C code. There is a good story about FFI by Joy Watkins, like wizard, hey, is a welder wand, use it wisely. Muggle, but how? I don't know. I know that if you wave it, it will work for you. But can I have a cloak for my protection? No. So, idea. What if we use PHP's FFI to access PHP itself? I want to put the slide also. The muggle in this story actually died. Wizard also died. But anyway, there is a library called that engine, and it's open sourced today, and it provides direct access to your PHP itself from PHP. It provides an API on top of reflection, like a reflection class, a reflection method. So if you are familiar with reflection, you should be familiar with this library. And it also contains low-level bindings for structures like zval, then class entries, and you can just imagine what you can do with such structures. And it allows us to manipulate PHP itself in runtime, for example, to change your method, remove it completely, but you should expect memory leaks and segfaults. Let's make our class on final with this library. We just create a final class and create a reflection, and we call set final false. That's it. At this moment, we remove Zend final flag from Zend class entry structure, and voila, we can now extend this class without any troubles. But for that, we need to initialize library. It's only a single one line called core initialize, and it performs low-level initialization and use it in preloading. What I want to show you is a serializable closure class. Have you tried to serialize the closure? Yeah? Have you succeeded? No? You can try one more time. If you add magic serialize method in your class, it can be serializable. And if we have low-level bindings to the closure class itself, why cannot we add a closure class directly, serialize method directly to our class? So let's do it. And yes, we have our own serializable closure class, and we can serialize it. And this can be useful, for example, to storing your closure in in message queues or maybe in database. You can create your own stuff. But what's funky is custom throwable objects. Have you tried to implement throwable interface by yourself? It's interesting, but we can create a class, empty class, add a simple toString method, and make this like an exception by adding throwable interface and throw it. And PHP trusts us because actually it's implements throwable, it has toString method, and we have like, oh my god, I can be thrown. Cool. It's cool to hack PHP, and I like it. But what I like more is to craft assembly method in PHP itself. Yes. Who likes assembly? Like me? Yeah, I know this guy. We have several instructions in PHP, like to load our string into memory and to perform a syscall from low level possible in CPU. It's a native source code, and after that we can add this method like traditional one into any existing class and execute it, and we will see a hello world from first ever assembly method declared in PHP itself. And you can expect more interesting features like API for user-defined PHP extensions, like opcode manipulation, like shared objects that can survive between requests, native hooks for PHP callbacks, much more. So this is the end of the story. Thank you, everyone. If you have any questions, please welcome.
Yeah, we have around 5 minutes.
Yeah.
Wait, and please wait for the microphone.
So, other questions? Yeah. First row. You'll execute a compiled version of your application. And overhead is only several milliseconds for execution of your method. Okay.
Okay, I have another question. Well, if you have this pattern like you described it, for example, the before function that is showing on the screen now, it's like something that's one-liner, right? It's above the beginning of the function, and then you have, what this does is replaces another one-liner which is below the initial like statement of the function, right? So what do you gain out of this? And isn't it an anti-pattern for PHP, or I don't know, I mean, this is usually a pattern that's used in Java and languages like this, and PHP is not built like that, and I think that it's for a reason. So do you think that it's a good way to go like this and implement stuff that is not meant to be in PHP in an enterprise environment?
So thank you for the question. Actually, we have a lot of application written in PHP for big companies, like financial one, like trading one, and we can use features from Java world. Actually, if you know about Symfony, it was ported like from Spring framework from Java, and we have dependency injection container. It's also actually from Java world. And if we have a look at Aspect.J or Spring framework closely, we will notice that there is a AOP part in this framework. And why not to have such a framework in PHP? So it doesn't matter which language you use. It matters how can you integrate it with your framework or library. For PHP, it's used well. So I'm proud that AOP framework is quite fast and is used for production for many companies. Okay.
All right. We are.
Okay. If you have more questions, we can discuss it in QA area. So please welcome.